Hey everybody, welcome back. It's Mr. G again. Today we're going to do power electronics. We're going to do lab number 11. It's on the DC Power Inverter circuit. This is a quick lab, very simple. This circuit is very simple. It is not a complex circuit of a power inverter. But if you remember from our lecture that we had, so there is a video that is posted for power inverter lecture. So if you didn't see it, have a look. Or if you have forgotten, take another look. The job of a power inverter is to convert DC into AC. So DC is direct current. AC is alternating current. So what we're doing is we're taking a DC, so that is current flowing in one direction and one direction only, and causing that current to change direction. Now this particular circuit that I have built is a very simple one. It's not going to produce a fancy, accurate sine wave, but what it will produce is actually current going in the opposite direction. So it's going to be a very rudimentary AC circuit. So again, there are much more complex circuits out there that will do a much better job than this one. But for what we are doing, this is really simple. So our circuit consists of a couple of resistors, a couple of transistors, the DC supply, a transformer, which we are running backwards. So we're actually going to come in on the primary side with the tap, and we're actually taking the secondary and out to our scope to watch. But we're running this transformer backwards. So what we're using as the primary is actually the secondary of our transformer. And what we're using as the secondary is actually the primary of our transformer. So our waveform is actually going to be coming out of the plug. So our circuit is feeding into the transformer, and then out through the AC plug is where we're actually going to get our voltage. So it's very important that if you're doing this experiment, do not plug in the transformer. So do not plug this into the wall. This is the output in our example. Okay, so the transformer that we have set up here, again, the plug, the AC plug on this side of the transformer is going to be our output, and you'll see I've got my scope probe connected up to that. So basically, very simple circuit. In the lecture video we discussed what happens is the current actually leaves this DC supply. One of these transistors turns on and the current will actually flow through the coil one way. Then it triggers the other transistor to turn on and current will flow through that transformer coil the other way and back and forth. And the changing of direction of this current through that transformer actually causes a change in direction of the current flowing on the other side of the transformer. So again, the whole key to this lab is to take something that is nice and steady DC and convert it into something that flows one way and then flows the other. Rudimentary AC waveform. And that's what we get tapped coming out onto this side here, and we're going to monitor it onto the scope. So here's what we've got. There's the two transistors. The resistors that we have in here for the first part of the lab are 1 kilo ohm resistors. So the 1K resistor. So what we're going to do, we're going to click this thing on. The input is going to be 3 volts. So we're going to put 3 volts as a DC input. We're going to take a look at what our waveform looks like. And we are going to measure the frequency of that waveform at 1K. So here's what we got. I'm going to turn on my power supply. I believe I have it all set up already. So 3 volts coming in off my power supply, and right there you can already see our AC signal. So I'm just going to drop that signal down so that we are right down in the middle. So that is a basic rudimentary AC. So the current is actually flowing one direction and then flowing through the other. So here we go, the current is flowing in a positive direction, and then the current flows in a negative direction, and then a positive direction and a negative direction. Okay, so here's the negative, here's the positive. So what we've taken is we've taken a single, DC supply and we've turned it into an AC supply. So we're going to ignore these spikes here. That's an artifact. We're going to get rid of those spikes. So what I'm going to do here is I am going to adjust this scale and see how much of this we can actually get. There we go. So what I'm going to do is I'm going to measure for you frequencies, and we're going to measure the voltage minus that spike. So if we look at the frequency is going to be 118 hertz. So 118 hertz is the frequency. And now what we're going to do is we're going to go and do some measurements. We've got this peak to peak here, and it's going to be fairly inaccurate because it's taking into account the big spike. What I want to do is I want to try and get to voltage at this point here down to this point here. So I'm going to measure peak to peak from here to here. I'm not going to measure the artifact. The scope is picking that up. So I'm just going to go into cursor, and I'm going to do this ourselves here like this. So I'm going to go up to that point there. So that's going to be the top of our waveform. And I'm going to go down to about here, which is the bottom of our waveform. And we're looking at roughly 6 volts, 6 down, 6 above roughly. So looking at about 12 volts of an AC waveform being created from 3 volts of a DC waveform. So again, we're not taking into account the artifacts, the spike. We're trying to level off. So if we looked at this as some kind of a sine waveform, that's what we're looking at. Okay, so again, this is being fed from our DC supply. It's coming out the transformer and off to our scope. And again, you can see that 3 volts of DC is being turned into approximately 12.4 volts peak to peak of an AC waveform. Again, it is not a fancy waveform. It is not a sinusoidal waveform. All we're going for here is turning DC into rudimentary AC. So that's what we've got so far. So what we're going to do is we're going to swap the resistors, and we're going to put in a couple of 2.2K resistors, and we want to see how that affects the circuit. So I turn off my power. I'm going to grab a couple of resistors that I happen to have here, 2.2K. That one. And then I'm going to swap in this one here. Inches there like so. So now I've changed from the 1K into a couple of 2.2K resistors. So we'll turn the power back on and see what our waveform looks like. So you'll notice that the waveform has actually increased in frequency. The voltage has dropped a little bit, okay? But the big thing that we're looking at right now is the frequency. So I'm just going to spread this out. Ooh, it's a little too much. So let's go in here and measure. So our frequency has jumped from what was about 111 hertz to now almost 400 hertz, so 392 hertz. our voltage has dropped a little bit. So our voltage is now, if we try and grab the same points as what we did before, our voltage has dropped down to about 10.8 volts. So you'll notice that our input has changed a little bit. So I'm going to bump that up. There we go. Okay, so our voltage, again, roughly, not too bad. Roughly about 11-ish volts. Dropped a little bit, but not significantly. Put a little bit more of a load on the power supply. So our power supply value input dropped. I just corrected for that. So our output has dropped ever so slightly, but not much. But the big thing is the frequency has gone up. So what I'm going to do, I'm going to turn this one off. I am going to pull out these resistors. I am going to pop in the next set of resistors, which is just a 100 ohm resistor. There we go. So those are 100 ohm resistors. So I'm going to turn the power on, readjust to make sure we have 3 volts coming in. And you'll see now our frequency has dropped and our waveform has gone up. So our frequency has dropped to 40 hertz. And the value of voltage has increased. So I'm just going to grab that part there. Our spikes are not as distinct as they were before. So now our voltage has gone up a little bit to 14.8 volts peak to peak. 15 volts, give or take. So the resistor values have a huge or a large effect, if you will, on this circuit when it comes to the frequency. So in this basic circuit, what is determining the frequency of our waveform is these values of resistors. Okay, so again, I've corrected for the 3 volts. Everything is good there. The waveforms themselves, again, they're not perfect, but they are AC waveforms, and that's what we're going for. So again, a very, very simple circuit, very, very quick, simplified lab. There are 4 questions for you to do at the end of this lab. Very good, very good. So what we've got, again, a Lab 11 Power Electronics DC Power Inverter. Very simplified circuit. What we've done is we have taken a simple 3-volt DC waveform and we have converted it into a rudimentary AC waveform. That rudimentary AC waveform is adjustable on frequency by changing the values of the resistors in the circuit. So these 2 resistors here in this basic circuit have a lot to do with how the frequency actually works, or controlling the frequency in this circuit. So those resistors are determining how fast and how quick these things are turned on and turned off. So they're alternating back and forth, and these resistors have a job to play with how fast that voltage actually appears to turn this one on and then turn this one on. All right, so that is the quick lab number 11 power inverter circuit for the power electronics class. Hope this helps. Everybody stay safe, take care, and we'll see you next time.